Perfect.
Welcome to Guatemala chapter, and you can start.
Thank you, Azadine. Well, thank you, people who are watching our presentation. We are from the OWASP Guatemala chapter. My name is Pablo Barrera, and with me is another member of the chapter, Diego Porras. So today we are going to talk about two different subjects. The first one is going to be about cyber resilience. Regarding these times we are living, I think resilience is one of the most important aspects we need to think about. So we are from Guatemala. We are pretty famous about volcanoes, about Antigua, Guatemala, and especially about our coffee. So I'm going to start with the presentation. And if you have any questions, please keep them until I finish. So, building cyber resilience. A little bit of who am I? I'm a cybersecurity director for Estrategia y Seguridad. I teach at university. I am a member and a leader of the OWASP Guatemalan chapter, and I have a few certifications regarding cybersecurity. I also like to play the saxophone, do some scuba diving, and cooking for my wife. The agenda for today is very simple, since we only have 30 minutes, and then we are going to have a session for questions. First, we are going to revisit some concepts. Then we are going to see how to plan for cyber resilience. Then how to implement that cyber resilience, how to measure what we are implementing, and how to improve it. Okay, so first we need to begin with concepts. Cyber resilience. Resilience is a word that has been around for 400 years. So the concept is act of rebounding or to rebound.
Pablo,
Yes, Asadi.
we have some echo.
Echo? Okay.
Yes.
Okay. Let me try with another microphone then. Hold on. Is it better now? Hello? Is it better now, Asadi? Okay. Can you hear me? Hello. Can you hear me?
Yes, it seems that there are two persons making the presentation. Yes, it's better. Yes, but it seems that there are two persons making the presentation.
Okay. Yeah. Diego was online too, so no worries. If it's better, I can continue.
Okay. Yes.
Okay. Thank you. So I was talking about first we need to understand the concept of resilience. Resilience comes from Latin, and it's a word that has been around for 400 years almost. And in the past, it used to mean to rebound or to recoil. And as we can see in the lower part of the screen, cyber is a word that usually we attach it to old words and make it really cool. So since resilience has 400 years and we use the word cyber, so it's a cool subject, right? But in the truth, resilience is the capability to recover or to sustain an attack. It doesn't matter how much we are under stress, but we thrive. That's resilience. We need to recover, we need to adjust. So in order to resilience, something that comes to my mind is this. This is something that I bet most of all are familiar with, the wall. So, but since I am a Guatemalan, I bet the wall is not as resilient as this. Okay? So this is Guatemala too. These ruins have been there for thousands of years, and they have lasted for even more. And they have thrived even though earthquakes, monsoons, fires, mudslides, predators, anything you can imagine, even a Star Wars movie. So resilience for me is to stand there. Doesn't matter what happens around you, doesn't matter what attacks you, but you have to withstand. So in order to understand cyber resilience, we need to go through some concepts regarding risk management. Why? because cybersecurity is just a small part of the whole risk management area or subject. We have information security, we have, for example, business continuity, disaster recovery, and we also have the technology management, which, in order to accommodate resilience in this Venn diagram, we should put it over here, like a small circle over there, because it includes a little bit of everything. So, what does cyber resilience means? It is a pretty neat concept, and it's the ability of a nation, because it can be a nation, an organization, mission, or business, to anticipate, withstand, and recover and evolve from the face of adverse conditions, stress, or attacks. So it means it doesn't matter who is attacking us, what's attacking us, or under which conditions of stress we are. If we hang it there, we are doing resilience. Okay. Then, in order to deploy resilience in a correct way, we need to do it as we do with all the information security and all the cybersecurity. We need to follow a continuous improvement cycle, which is first, I need to plan what I am going to do. Then I deploy that plan, or I do the actions that I was planning. Then I check and analyze if those actions were the correct ones, or if they are working in a proper manner. And then I act based on that check. So that helps us to deliver a continuous improvement to our cyber resilience program. So the first part is planning, okay? How do I plan? In order to plan for cyber resilience, we have to bring forward another concept, which is cyber resiliency engineering. Why? Because I bet that someday in the future, in organizations, we are going to have a chief resilience officer, the one in charge of resilience for the whole company or for the whole organization. Why? Because this is a science almost. We need to understand that cyber resilience engineering has to do with systems security, has to do with system operations, has to do with performance and management, and also with other areas of the organization. So we need to think in an engineering way in order to improve, to adapt cyber resilience. So how do we do it? Okay, we need to plan and implement cyber resilience. The first thing that we need to think about is how we are going to avoid or how we are going to anticipate. After that, we need to understand how we are going to withstand or absorb attacks. After that, we need to understand how we are going to recover from those attacks, or how we are going to restore to 100% of our functions. And then we need to adapt, we need to change. For example, some organizations in Guatemala right now, they used to be hardware stores, but since the COVID crisis, they have turned into supermarkets and they are doing delivery. And a lot of restaurants are closed, but they are doing and selling delivery. So they adapted to the situation. And the same thing happens to our cyber area of the organization. Some organizations have developed remote work policies, remote work technology. So a very important area is to adapt. Okay, so what do we mean with anticipate? We cannot predict the future like reading a magic ball, but we do have some sort of, let's say, functions and prerequisites in order to anticipate what is going to attack us. For example, we can do some threat modeling. Threat modeling is another interesting subject that we can dig deeper a little bit, and I recommend you to read about Shostak in threat modeling. It's a very interesting author. We can do risk assessments. We need to understand the risks of our organization in order to develop the right controls or the controls that we need to implement. We need to do, for example, vulnerability analysis. So when we are talking about anticipate, we are talking about predicting, to understand what can happen to us, what can happen to our organization, what can happen to our information security infrastructure. After anticipation, we need to understand withstanding. Yeah, for cyber resilience, to withstand is to continue the essential processes. So in order to understand and to do the withstanding, if we remember, we need to understand which are our risks, which are our more important assets that help us to produce our most important product or to do our most important processes. So in order to withstand, we can have things like a SOC, like a blue team, like incident response, for example. And then we need to recover. This is really nice. We need to recover. Okay? What is recover? To recover is to restore our functions to the maximum extent. Because if we are under attack, we are going to have some loss. And after that loss, we need to understand how and which actions we are going to take to recover in order to gain our 100% productivity again. After recovering, we need to learn how to adapt, okay? So adapt, what do we mean by adapting? By adapting, we need to change. We need to change in order to comply with our customers, to comply with our systems and our needs as an organization. And in order to develop a cyber resiliency effectively, adapt is one of the most important parts because it says what we are doing to achieve the desirable outcome. What are we doing to comply with the needs of the market, with the new needs of the market? So if we go back and we go to anticipate, for example, it comes to my mind those guys who sold all their stock actions of airlines. They knew what was coming. So they decided to sell all their stocks, all their American Airlines stocks, all their United Airlines, everything they had about airplanes, everything they have about cruise ships. So that's anticipating, and I am positively sure that they did some threat modeling and some risk assessment regarding that. And if we want examples of withstand with these crises that we are facing worldwide right now, we need to look at countries like, for example, Costa Rica, for example, Singapore, Korea, even though China. So those are countries that are withstanding even the crisis. Germany, for example. And if we need examples of recovery, we need to understand which areas have been more affected. For example, education. Education is an area that has been really, really affected by COVID, for example. And in order to recover, we are going to do a lot of steps before going to classes again, before opening schools, before students can go to school again. So that's a good example of recover. And if we put it in a cyber example, a good example of recovery is our telecommunication companies. They were not prepared sometime for the amount of data they are delivering right now from the houses. And they have been deploying optic fibers, they have been deploying more radio stations and more infrastructure in order to allow people who is now doing most of their work from home to have an effective bandwidth. Okay, so that's a good example. And adapt. Regarding adapt, we can talk about, for example, those restaurants that I was talking about that are now doing delivery instead of getting their customers into their tables. And if we want to see this from a cyber perspective, adapting is what most of the businesses and organizations are doing to enable their workers to work from home. I've been looking to, for example, to the call center industry. They have been enabling thousands of collaborators to work from home in order to keep their processes going. So when we are going to develop a cyber resilience program in our organization, we also need to measure that program, and there is no need to create sugared water. There is a lot of things that already exist that we can use in order to develop those kind of programs. So when we talk about cyber resilience, we can go to NIST, for example, to the cybersecurity framework. They have a lot of controls that can help us understand how to enable and how to measure how cyber resilient is our organization. Another good choice is ISO 27001, for example. It, there are controls there that we can implement or that we can assess in our organization. And also INCIBE. INCIBE is a really nice place where we can find metrics and controls that we can apply to our cyber resilience program. So regarding this, I would like to understand if you have any questions regarding the presentation. I don't know. Sorry. No questions so far? Reading. Okay, thank you. Well, if there are no any questions, I'm going to give the staff to my friend Diego, and he's going to do a conference about cyber ops, if I'm not wrong. So thank you very much for your time. I know this was very brief, but I like to keep things short and understandable. If you want to ask any questions, you can write to my email. I'm going to put it right now here. So my email is okay. Well, thank you anyway, and let me know if you have any questions. You can write me to my email or you can share your thoughts on the YouTube video. Thank you very much. Have a great day.
I don't know if I'm already.
Diego, yeah, so you need to make some presentation. I added you in the so you can share your screen.
Yeah, I'm sharing my screen. Can you see that? Is now, is it visible now? Yeah. So I think we are good to go. I'm sharing my screen. Okay, there we go. So hello, I'm Diego Porras from Guatemala OWASP chapter. Thanks to all the people that is watching this live presentation or recording. Um, I will be. I will try to be concise. The name of the talk is Task Zero: Hardening as Code, and the subline is Protecting Your Systems Before They're Born. So, giving you a little of context, usually when we develop systems, any sort of system, we end deploying those systems and applications into platforms. There are a lot of planning going on before launching these systems. So, from the security and compliance perspective, there's a need of planning ahead the security and hardening for these systems in order they to become resilient, cyber resilient, or more secure, right? So this is what this talk is about. We will talk how to harden or plan for those systems to be secure, do that in advance, and scale up by automating these tasks. So a little bit about my background. I'm an application security engineer. I love automation and cloud. I worked as a pen tester, but currently I develop the application security program for a company. So a note here: if we run out of time before I can end with the demo, that I think is the most useful part of this presentation, you can check my website. There's a series of blog posts to be launched the next week here. So maybe you get the insights and the content from there. Okay, what is the context? As I mentioned before, we have long supply chains or production chains for software. We develop code. We use source code management tools like GitHub or GitLab, whatever it is. We gather requirements. We design those tools. We develop, test, and deploy those tools. Usually, the secure development lifecycle handles a lot of security tasks in an early manner. For those, we have a lot of resources in the OWASP. That's great. We have security assessment guidelines. We have security requirements and best practices. So that's great. Security development lifecycle works and works good if you train your developers and your operations teams and implement that. So let's assume we already know how to build a secure application. So that's great. That's the best case scenario. But what happens when you develop a secure system with secure coding practices and automation and so? So we still need to deploy those applications. Is that I don't know, an internal chat server, a machine learning system or API or whatever technology or software services your company is offering? You need to put that software in a place. Nowadays, we have a lot of cloud providers: Amazon, Microsoft, Azure, Google Cloud. We can use technologies as Docker containers, Kubernetes for orchestration. We can even have on-premise systems, like deploying on virtual machines inside our data center. We can use automation tools like Vagrant over VMware, and so we have secure software and we have platforms for deploying. But there comes some interesting part of the business: compliance. It depends a lot of what business vertical your company is running, but we have a lot of privacy and data protection regulations across the world, across the planet. So give me a second. Okay. For example, if you are working with health insurance or hospitals or healthcare, you need to be compliant with HIPAA. Or if you are offering services like websites or applications to European countries, you need to be GDPR compliant. If you are processing credit card or payments in your applications, you need to be PCI compliant. So there are a lot of legal regulations you need to follow depending on what is your business model and industry vertical. You can even, if you have a robust security and compliance team, you can even have internal policies and standards. So the documentation is there. The guideline of what makes a system secure and compliant is there. So how you translate those information into an actual secure and compliant system. So we go to the next step. Traditionally, compliance teams develop requirements, documents, checklists, and compliance and security teams handle those documentation to the infrastructure or DevOps teams. So the engineering teams are in charge of make the checklist happen in the actual system. So you have two sides there. But what happens when you develop a security requirement or a compliance requirement for a web server? But it turns out that your company is a big company, and that requirement that compliance team developed for your team needs to be applied in 100 systems, 1,000 VMs. Maybe you have a continuous deployment setup when you start instances and you take down instances according to the workload you're having. So there's a lot of considerations into this. So you have the information, you know what is need to be done, but how you do? Usually, some engineers take care of configuring the web servers, the virtual machines, the EC2 instances, harden the Docker containers. So that's great, but that introduces a lot of overhead in your teams because it's not feasible configure one by one the systems. You need to have a better way. So I took this line you can read here from the DevSecOps.org website. It's a nice website with a manifesto about what DevSecOps is, or aspirational manifesto on what DevSecOps should look like. And this line says, compliance operations over clipboards and checklists is what I'm talking about. Is the core of this presentation. So instead of developing a checklist and make your engineers implement that checklist in each system, why not we evolve our processes into compliance operations? An operation is something you structure, you have clearly defined, and that is repeatable, and in the best of cases, automated. Nowadays is really useful and easy automates things. So with compliance operations in mind, we get to this concept. This is a new project OWASP is launching. The DevSecOps guideline is in a very early stage. I just took the screenshot from the website. But look the diagram. We have the source code management. We perform static analysis on the source code in order to spot bugs early. We automated some of the security controls your pen test do manually. There are a lot of things you can automate into Dust. You also scan your SSL certificates, your open ports, whatever you want to scan in your infra. But there's a key component, compliance check. Okay, going back again. You build functional systems, secure systems. You have a pipeline or a procedure for deploying those systems, but there's a, let's call it a box. There's a server that is in charge of keeping your system, your application alive. So what happens with all the regulation we talk about? You need to be compliant. And in DevSecOps, there are a lot of ways to be compliant in an agile, very fast, and very automated fashion. So let me introduce you to Ansible. Maybe you know Ansible before this talk. This is a configuration and deployment tool the infrastructure teams are using nowadays. Configuration management is all about automating how your systems should look like in production. So let's say You require a system to have the version one of one package instead of the version two for compatibility reasons or whatever it is. So you create a structure, a script, or a YAML file that says, okay, these configurations need to be in place. So that's Ansible. And I took this green block from directly from the Red Hat page. Red Hat is the company in charge of maintaining and building Ansible, but it's an open source project, so that makes it great. When you automate, you accelerate, and that's a very catchy phrase because it's true. If we want to develop better and faster, we need to automate and automate in the right way. So that's the whole purpose of Ansible. Okay, now we understand we are working with platforms, with boxes, and that we have tools for automating or declaring the state of the configuration for those systems. That's configuration management about. Now we start talking about compliance. Where is compliance in all this thing? So we get to this other tool, Inspect. This is made by Chef. It's a company that builds private software for DevOps and that sort of things. But this Inspect product is open source and is really useful. So Inspect basically is based on Ruby. It allows you to define some scripts like the one you see here, and is intended for people that aren't actually software engineers. From my experience, I know how to code, but from my experience, I can tell you that this syntax is very, very understandable. So Inspect allows you to define a set of controls in a programmatically way. So you define, for example, in the system you are working with, there should be a package called telnet, and we want to make sure that package is not installed. This is a generic example, but why things like this are important? Because we know telnet doesn't implement TLS. It's a plain text protocol, and actually there's no reason why you would have telnet these days. But alongside, we know telnet shouldn't be in the systems. We need a way to ensure telnet is actually not installed in the systems. So this is what Inspect is about. Easy syntax, easy objects, understandable objects you can use to match configurations, match the state of the system against the desired or the compliant state. So these are the two tools we will be discussing in this talk. And with that in mind, I prepare a small demo. Why? Because I can talk you about how things, about tools and how things need to be done, but it's not the same if I show you how do we do it live. So for this reason, after this talk, I will share with you. I create a couple of ASCII Cinema scripts here. We can follow along. So we have like the live tutorial for what we are doing. So the scenario we are working with here is I deploy a web server. Almost all companies use web servers. So I deployed a web server inside a container. In this case is LXC. I didn't use Docker because I don't know the reason. LXC is easy to use. I deployed a web server. Now I need to deploy a web application or a web page on that web server. But how I make sure that web server is secure enough for being placed in production? So that's the question. So we start with our ASCII Cinema. If you have any question during the walkthrough, please let me know, and I will explain. So for this demo, I used Ansible, with a playbook. If you see, we are working with this web server here. I built a container with an IP called OWASP demo. After that, I use something called Ansible Playbook, a YAML file, an inventory, and some credentials. I want this. This is not a talk about how to use Ansible, but I want to make some things clear. Ansible Playbook is an utility that allows us to run playbooks. That sounds redundant, but that's the concept. In Ansible, if you want to accomplish anything, you define a task, install a package, remove a package, delete a file, modify a file, add an SSH key, remove or add an user. All those are examples of tasks. And these tasks usually need to be performed when you are creating the systems. So Ansible playbooks are collections, tasks, and look exactly like that. I don't know if that's visible on my screen, but this is an Ansible playbook.
Diego, excuse me, the font screen is small. If you can resize it, because it's not visible in YouTube channel.
I just resized it. I don't know if now it's visible. Is it okay now?
Now it's okay. You can continue. Thank you.
Okay. So what is a playbook? A playbook is a YAML file. If you are not familiarized with YAML, these are configuration files that use indentation, spacing, and are like dictionaries or hash maps in a programming language. When you define a key, all these blue words, and a value, all these orange words. So in a YAML file, you define which host you will target, some configurations like the users you will use during the tasks, and which task you are performing. So you give a name, you give a command, and you can like log things. So this is a very basic playbook. First, I check if Python is installed on the system. If not, based on this variable, I install Python 3 on that system, and then I deploy a private key. The purpose of deploying a private key to the server is I need to be able to manage that server without human interaction, without inputting passwords every time I'm doing some configuration changes. So this is a very basic Ansible playbook, and this enables a remote machine for Ansible management. So when I run this script using Ansible playbook command against any server, Docker container, EC2 instance, virtual machine, Ansible now is capable of interacting with this system and passing instructions. So going back to the let me see. Going back to the ASCII Cinema, if you see, I'm just launching this playbook against something called an inventory. An inventory is basically a text file that includes the IP addresses of the software you will target, the system you will target, and this is some access flags like saying I'm logging as the Ubuntu user, but I want to become root, and please ask me for the root password while I'm logging. I use these flags in the example because I want to stress the point that you shouldn't allow SSH access to the root user. I know in this demo there will be cases when you will see root access there, but it's just for demo purposes. Please make sure all your production systems don't allow the root user for SSH or remote logins. It can be SSH or RDP. Just make sure that that's in place. So I run this playbook. This playbook, as I mentioned, is provisioning or making my target server being able to be managed by my Ansible machine. So if you see, It tests if Python is installed. As Python is already installed, it skips the installation and it deploys a private key. Now I'm able to administer this target host. So moving into the demo, we have a functional Nginx web server until now. Now I did some manual tweak here because I generate a pair of SSL certificates just for demo purposes. You can generate SSL certificates using a third party or automating the SSL creation via Ansible. It's doable also. So you may have a process for issuing SSL certificates. I did it manually because of the demo, right? So deploying a basic web server. Now that my target server can receive automated instructions, I want to automate the creation of the server. So we have two ASCII Synema scripts here. As I mentioned, these are published. So if you want to watch this offline and see all the commands and output, is available for you. And let's say, so again, this is not an Ansible talk, but I want to make the things clear before we pass to the compliance thing. So this is another YAML file. I instruct which servers will be affected by this. I pass some configurations like the website name, some title. Here I install Nginx. I create a web directory for hosting my websites. I modify the main configure file based on a template. This is a concept of Ansible. You can template your configurations so they are not fixed. They are dynamic. Let's say if you want a configuration for server 1, but for server 2, you don't need to have two files specifying. You can have the same file as a template and passing the parameters that are different between the two servers can be passed as variables. So this is the usage for this template task here. Then I have a task for creating a virtual host. Virtual host is something you use in Apache or Nginx for having multiple websites running on the same web server. Let's say you have one machine, but you can have mycompany.com, mycompany.org, another site.com, something like that. That's the meaning of a virtual host. And finally, we want to perform a safety check of removing default virtual host configurations. As a rule of thumb, when we are configuring systems and talking about security, we want to avoid all the default configurations. I know this is a lot of overhead, but please make sure your systems don't go to production with default settings. Even in staging or development environments, make sure you remove default configuration, because you don't know where a system will be reached by an attacker, and default configurations can be an advantage. So this playbook installs Nginx and creates a web page. So running the playbook, you see, this creates the web server. This instructs Ansible to target a machine I specified, and these are the credentials. If you see, Ansible run many tasks as okay, change some configuration as I told you before, and throw an error. So you say, is this a demo? Are you showing me a demo with errors? That's the whole point. Telling that sometimes things cannot work, you will face errors, but you need to overcome and do some debug. In this case, if you face this when you are trying these scripts I'm sharing, make sure you give a couple seconds to the server to restart. This is just a restart task that fails. So be patient, and you can rerun the script. And if you see, this is the same command line, and everything worked. So notice the difference. There's no yellow mark on the configuration because the configuration is in place. So that's a great advantage of configuration management and Ansible, and that's why I'm recommending this to you. If some setting is already in place, you don't need to rewrite the setting. It checks, okay, this is the desired configuration. The configuration is already in place, so I don't need to change anything. I will speed up things and continue with the needed tasks. In this case, it only continued. The server is restarted, and now we are good to go. So any questions so far? We provision a system for being in order to manage from the Ansible machine. We created a web server, and now we will make sure that web server is secure enough and compliant so we can put it in production. So look this title, filing at compliance checks. And that's very important. This is the whole purpose of this talk, showing you error screens. Because if I only show you green marks, everything works like a charm and you got a good taste that the tool just works. But what happens when you're in production and you see all the error messages? What would you do? Yeah. So I'm providing here like some guidance on how to troubleshooting things. So there's another ASCII Cinema script here that I will show you. Sorry if I'm going too fast but I want to make sure we get to the end. After the talk, I can share the resources with you. If you have any feedback or question, you can reach me via many sites. Okay, so notice the title of this slide, failing at compliance checks. So we provision the machine, we create the web server, we deploy that page to the web server. Now let's check if that web server is compliant. So for this, we make our first run of inspect. Again, I will share all these resources with you so you don't take things for granted. There's nothing without the proper documentation, and we are talking the same language. So I installed the inspect command via a Ruby gem because inspect, as I mentioned, I will disable Grammarly because it's like being very intrusive. I install inspect via Ruby gem. I will show you the documentation where you can learn how to set up this. I'm issuing exec command. So I'm telling inspect to run some GitHub repo. This looks very, very odd. It's weird, but let me explain. I'm using SSH passwordless authentication. This is because if you remember the first time we ran Ansible, I deployed an SSH key. So this is the whole purpose of having that key, that my system is now able to interact with the remote system without a human being in front of the screen and the keyboard. So I instruct to use some SSH key. I specify the target, the same web server, the root user. Please be advised that inspect have the means for using regular users and escalate privileges. So please don't use this line. It's just for demo purposes. And I'm instructing him inspect to use SSH protocol with this user with this IP. This could be a Docker container. This could be whatever system you have in place. It's not compulsory that you use SSH. And this also works for Docker containers like a charm. It's a really good tool. So I'm executing against this system using this authentication, using this spec tool. I'm running this inspect profile. You have two options: running inspect profiles straight ahead from the GitHub, or you can run inspect profiles locally. So I just wanted to show you this part, but I'm showing how to run the local profile. Why I'm using this? Because inside this hardened directory, I have a Nginx baseline. That Nginx baseline contains this same repo, but I cloned the repo beforehand. So with a command line as easy as this, that you will have after this talk for copy and paste, we see a lot of debugging errors there. I will just play this. And we got a lot of red marks. So please let me explain this to you. Okay, why we have so many red marks? Look at this. This is bad. This is really bad. The inspect profile we are running contains controls. Inside each control, you perform some check. After you perform if check, the check could pass or fail. There are only two states, or is compliant or is not compliant. So all these red marks are uncompliant things I need to fix on my Nginx server. But see, are 12 controls. Imagine handling 12 uncompliant configurations per server by 10 or 100 servers, I don't know. It's a lot of work. So here comes the magic. We failed the compliance checks. That was our intention. Now we have a diagnostic or an overview of what is misconfigured. Now we can fix. Without knowing what needs to be fixed, you cannot fix. So let's get to the next part. The system we provisioned in the previous step, now we checked, it breaks many compliance checks. So you will ask, okay, but what are those compliance checks? For example, I have some TLS things here. Acá is in Spanish. Here, I have some cipher suites. I will explain this in a moment. We fed the compliance checks. So hardening via Ansible. And this page is called DevSecIO. And it's a very useful page. I will explain. DevSecIO, if you remember the CIS benchmark, if you are in compliance from a couple of years ago, like the past 10 years, we have used the CIS benchmarks. Those are set of secure configurations you can implement in your Windows systems, your Docker systems, your VMware systems. There are a lot of compliance configurations and documentation and things. Okay, this website, DevSecIO, is an open source website that offers you many compliance, both checks and configuration for your system. For example, MySQL, Postgres, Nginx, Apache, Linux, Windows, firewalls, and firewalls is not include firewalls. So from here, we take this Nginx baseline, and this is the inspect profile. This inspect profile is checking, for example, for the running processes, for who is able to read and write the Nginx configuration, default files, and there is a long list of hardening or checks this profile is performing. So you can download the profile from here, see what the profile contents are, and making your systems secure. Have this red screen present because we are going to the good stuff. So I wanted to show you that an off-the-shelf system will fail many compliance checks, because if you just place a box, that box is not secure. You need to make it secure. So because of that, I showed you the failed checks. Now, let's go to the hardening. So how do you fix the previous screen? How do you fix this thing in order to become pristine. How do you do it? We are talking about 28 tasks, 27 controls. It's a lot. Think about how much time your infrastructure engineers will take to go through all these bullet points and configure each web server. It's a lot of time. So hopefully we have not only compliance profiles that the open source community already made for us, we have hardening playbooks the open source community already made. So take this with 2 grains of salt. The fact that there are open source hardening guidelines and automations doesn't mean you can just run those hardening guidelines and your system it's okay. No, it's a big advantage, but make sure you customize and double check what those tools are doing, because this is the example. So again, an Ansible playbook, we run our playbook. There was a minor error. You will check at the end of the talk what it was about. But we just ran something I downloaded that is called Nginx. What is inside Nginx? Let me show you what is inside. I think I didn't include that screenshot. Oh my bad. But let me show you. I have a bigger machine where I oh you shouldn't be able to see that. Let me show you what is all about. So is as simple. How do I need to close many things here in order to be able to show you. Okay, I think please confirm if that's visible. Those are development virtual machines I use. There's nothing like confidential there. I use spin-up machines for playing and the like. But if you are right, even I can see that. Sorry for the mess, but you see this little playbook here at the right? So this is a playbook like the ones we ran before, but it's including something called an Ansible role. So my advice, please check DevSec page and Ansible roles, because this thing makes 80% of the work. It will help you a lot. So we ran some hardening profile against the system. It performs various checks. We are running out of time. It performs various checks. Oh, it only fixed one of the missing controls. What do we do? So we deployed the system, we check that system, and now we are sure that system is uncompliant. We ran a hardening guideline, but the system is still uncompliant. So what do we do?
Diego, we have only 2 minutes.
Okay, so going fast to the last part of this presentation, we have another playbook. I will share this with you after the presentation. And we did some custom configurations on that profile. Okay, this is the profile. After we configure the profile, this is all open source. I will show you what changes I made. But after those changes, see, I ran again the compliance check, the same baseline, and see how it changed. There's 5% of the work missing here. You need to do that work. I can explain you offline how to, I can orient you. But the thing here is you have a lot of open source resources for automated compliance checks and automate hardening. You can take advantage of tools like Ansible and Inspect for maturing or customizing your compliance checks, and you can embed this inside CI/CD pipelines. So this is done in an automated fashion. So that was the purpose of the talk. Sorry for being for take too many time, but the purpose is please be compliant, harden your system, be secure. DevSecOps is the best thing you can do. DevSecOps is love. You can automate a lot of security tasks, and please automate. So that's the outcome of the talk. If you have any talks, please let you in the chat. You can reach me on my website, as I mentioned. I have my email there, and that's all from my side. Thanks for your time.
Thank you very much, Diego. For attendee, keep connected in our OWASP YouTube channel. We'll move to the next presentation from Atlanta chapter with the good presentation called Cooking with Pasta. And if you have, we have 1 minute. If you have one question for Diego, and maybe you can put your email, and maybe they can contact you.
Oh, for sure. There in the website
Diego, you can write your email in the comments, so they can, if you want.
You can reach me in this email. Also, my website is my GitHub page and my contact form. So
Thank you.
feel free to reach me. Thanks for your time, people.
Thank you very much.
Enjoy the OWASP event.
Thank you. Thank you.
Bye
Bye-bye.
bye.
Bye.